All right, lesson 7 is fairly short. It's only 2 tutorials and 1 exercise, and we're going to cover direct modeling. So far we've done parametric modeling, okay, which is very mathematical, um, systematic. It allows you to go back and revise sketches and see how, say, for example, scaling something might affect your overall design. We've done freeform CAD, which lends itself to creating maybe something more ergonomic with a lot of different curves in different axes. And so it certainly has its place as well. Like, for example, making this saw housing. But you don't have the ability to as easily go back and manipulate your existing design in freeform modeling. Now we're going to, in lesson 7, practice direct modeling. Okay, and so that's where you're interacting with your piece directly, where you're highlighting profiles and extruding them in certain axes. So it's something that you can use within parametric modeling to kind of, it's a very straightforward, simple approach to seeing how your design can be updated and maybe look aesthetically or whatnot. So we're gonna go ahead and practice that a little bit here in lesson 7-01. And the first step is to open up the reciprocating saw file that you probably already have stored somewhere. So I've already opened mine up. Go ahead and do that for yourself. So in this, we're gonna use component visibility options. All right, we're gonna use Fusion 360 modified tools, and we're gonna use the press pull function, which in direct modeling, it is analogous, in parametric modeling, it's analogous to creating a sketch and then either extrude cutting or extruding and creating a new form body. So press pull kind of does the same thing. In the browser, expand the bodies folder and turn off visibility for body 40. Okay. Okay, there we have it. Also turn off the visibility for the reciprocating saw assembly component. That's all this jazz. Under where? Under only body 19 should be visible. The assembly component, reciprocating saw. There it is. Okay, it was way down the list. Couldn't see it. So the assembly component, we're gonna turn that off as well. Trigger, let's turn off all the components. And the only thing that should be visible is body 19, which is this guy here. All right. Rotate the model and select one of the faces inside the vents. Well, first here, let's hop back up. 2 different methods for adjusting geometry in Fusion 360 are parametric modeling and direct modeling. Okay, so that's what we were getting at earlier. Parametric modeling uses parameters to control adjustments. So again, it's the mathematical approach. Direct modeling is where you're physically interacting with your model. It's more straightforward. It's not as mathematical. So in step 3, rotate the model and select one of the faces inside the vents, and notice the feature that created this vent is highlighted in the timeline. Okay. So we're going to zoom right on in. Okay, and there it is. And it's highlighted in the timeline. Looks like right somewhere. Let's scroll through our timeline here. Okay, it's highlighted right here. See that? The 3 dashed lines right here? Those 3 dashed lines pop up when I select, and it was a combine function there. Okay. Oh, that's the next step. Notice that the 3 dashes are added above the timeline operation. This is a combine operation. It is not the actual operation that created the event. All right. Right click on the selected face and choose the Find in Browser option from the pop-up menu. Okay. And it shows body 19 is highlighted by dashes in the browser. This method did not help find the operation that created the events either. Expand the browser's sketch folder and search for the sketch used to create the events feature. After finding the correct sketch, right-click it and choose the Edit Sketch option from the pop-up menu. So right now we're just trying to find what made this here. And neither of those two things work. So now we're going to go to Sketches. Let's zoom out a little bit. Okay, and we're just going to toggle through them until we find what sketch made the vents. Looks like this one here, sketch 48. I might rename this vents. Okay, that looks right. Let me continue down and just make sure. Yeah, okay. So there it is. Turn on its visibility and click Edit Sketch. Great. Here it is. In the Sketch Palette control panel, activate the Slice option to make the sketch easier to see. Add a dimension of 12 millimeters between two of the vent's parallel lines and notice how the geometry updates. Click the Finish Sketch button and allow the geometry to update. Okay. So what they're saying here is they want us to, under the Sketch Palette here, click Slice. All right, and that allows us to see the plane that we're working on. And the other thing they want us to do is to add a dimension. Add a dimension of 12 millimeters between the two vents' parallel lines. Okay, so dimension between here and here. It's at 15. I want it to be 12. Okay. And I believe that's all they want us to do. Click Finish Sketch. All right, and see how the geometry updates. This might take a second. This is a big file with a lot of different features, and so when you go in and make a change like this, depending on your internet speed and so on, it may take some time to compute. I'll pause this video till it's done. All right, so after 20 minutes of computing, here we are. You can see that it has updated the slot size as we wanted, but we have several errors in our timeline, which are highlighted by these red boxes here. And that's because whatever change we made here created errors further on in the design. After the model rebuilds and updates, the timeline displays several errors. These errors occur because subsequent geometry was based on the vent geometry that we just changed. And it can't resolve because the changes that we made. So click the undo button. Great, so all that waiting just to do that. And hopefully it doesn't take as long. Good, it didn't. So the parametric modeling in this instance is not an efficient way to adjust the vent geometry. We got to do something else. And we're going to turn off visibility to vents. And go back to bodies, turn off this. It is off. Let's see here. Shift. Okay. Just a sec. All right, so I actually had to click on undo several times to get back to this point, and here we are. Okay, to use direct modeling techniques for adjusting the vent, click modify and press pull. So we'll come down here, back to our vent, modify, press pull, first thing. Select the face in the vent and then use the on-screen manipulator to move the face to a new position. Click OK after adjusting the selected face to a new position. All right, so there's that. And you can see now that we can drag the face in, and even the fillets are updating, right? So we could effectively make the vent 12 millimeters as we had wished it was before. We'll just do that. Click OK. Oh my gosh, my computer is slow right now. I don't know what it's doing. Drag it back. Okay. And click OK. Enter. Oh, sorry. This is a hardware malfunction here, not anything else. Let's see. Might be able to. Okay, I finally got this to work. Simply because my computer's being really laggy, but we can tell because that vent is shorter. And also notice here that we have this offset plane here, which is the modification that we just made. Notice the new feature is added to the timeline to capture the adjusted face. Yeah, same thing. To adjust the remaining vent faces, either a new feature can be created or the original operation can be modified. So right-click the timeline feature and select Edit. Hold Control and add 2 more faces to the original selection. Click OK in the control panel to accept it. So we can go like this. We can edit the feature, and we know this is going to really be slow and laggy, which is annoying. I'm going to hold Command on my Mac and select this guy and this guy. And notice these are all going to be moved by a distance of 3 millimeters, or I guess in the tutorial they had 2 millimeters. So we'll go to and click Enter, and they've all been adjusted accordingly. Navigate to the front view and notice that the direct modeling techniques allowed you to modify the vents much more efficiently than the parametric modeling techniques. Navigate to the home view, save the file, and continue to the next module. So this was more straightforward because if we had done it parametrically, which is through the sketch, the original sketch, there were negative implications of that to the rest of your model. And in this case, it was much quicker and much easier. Now, if we're talking about parametrics, you can sometimes set up your parametric model to avoid situations like this. It's not always the case, but a case example for our vase, we set up the parametric functions so that we could go back and update it without, say, having errors or negative implications to other parts of the vase. That was from a few weeks back. So at any rate, I mean, sometimes it's avoidable if you've thought of it as you design in your sketches. But then, of course, there are times like this where it's easier to use and more efficient to use direct modeling. All right, on to the next module.